Given the function f of x equals the square root of the quantity 4 minus 2x, determine the domain and then graph the function. To determine the domain, we need to recognize that for a square root function, the radicand must be non-negative, and therefore to find the domain, we need to solve the inequality 4 minus 2x greater than or equal to 0. To solve for x, we subtract 4 on both sides, which gives us negative 2x greater than or equal to negative 4. So the next step, we need to divide by negative 2, but when solving an inequality, if we multiply or divide by a negative, we also need to reverse the inequality. So we'll divide by negative 2 and also reverse the inequality. Simplifying, we have x less than or equal to positive 2. This is a domain as an inequality. Let's also graph the interval on the number line. The interval includes 2, so we have a closed point on 2 and an arrow to the left approaching negative infinity, which indicates, using interval notation, the domain is the interval from negative infinity to positive 2. The interval is closed on 2, or includes 2, and therefore we use a square bracket to the right of 2. And now let's graph the function f of x as a transformation of the basic square root function shown below. Recall, if we have a transformation of the basic square root function, we can write the function in the form of f of x equals a times the square root of the product of b and the quantity x minus c plus d, where the values of a, b, c, and d indicate the type of transformation. However, to determine the values of b and c, we are going to have to change the form of the expression 4 minus 2x. Let's work on this first. We can write 4 minus 2x as negative 2x plus 4. And now let's factor out negative 2 and write the expression as negative 2 times the quantity x minus 2. Notice if we distribute, we still have negative 2x plus 4. This is the form we need to identify the values of b and c. We can now write the given function as f of x equals the square root of the product of negative 2 and the quantity x minus 2. In this form, notice b equals negative 2 and c equals positive 2. b equals negative 2 indicates two transformations. Because b is negative, we have a horizontal reflection, and because the absolute value of b is 2, we also have a horizontal compression by a factor of 1 divided by the absolute value of b, or a horizontal compression by a factor of 1/2. So again, we have a horizontal reflection because b is negative, and because of the 2, we have a horizontal compression by a factor of 1/2. So it's and a horizontal compression by a factor of 1/2. And then because c equals 2, we have a shift right 2 units. And now to perform the transformation, we'll use these 4 key points on the graph of the basic square root function. For the horizontal reflection and a horizontal compression by a factor of 1/2, we'll multiply the x values by negative 1/2. The negative will give us the reflection, and the 1/2 will give us the compression by a factor of 1/2. And again, this affects the x values, not the y values. So starting at the point 0, 0, negative 1/2 times 0 is still 0. The corresponding point on the new function is still 0, 0. For the point 1, 1, the corresponding point is negative 1/2 times 1, 1, or negative 1/2, 1, which is here. The corresponding point for 4, 2 is negative 1/2 times 4, 2, which is negative 2, 2. And for the point 9, 3, the corresponding point is negative 1/2 times 9, 3, which is negative 9/2, 3, or negative 4.5, 3, which is here. Let's go ahead and graph this function. Again, this is the graph of the basic square root function after being horizontally reflected as well as horizontally compressed by a factor of 1/2. And then finally, because c equals 2, we need to shift this graph right 2 units, which also affects the x values. We will now add 2 to these 4 key points to find the graph of the given function f of x. Starting with the point 0, 0, the corresponding point is 0 plus 2, 0, or 2, 0. The corresponding point for negative 1/2, 1 is negative 1/2 plus 2, 1, which is 3/2, 1, or 1.5, 1. The corresponding point for negative 2, 2 is negative 2 plus 2, 2, which is 0, 2. And for negative 9/2, 3, the corresponding point is negative 9/2 plus 2, or negative 9/2 plus 4/2, 3, which is negative 5/2, 3, or negative 2.5, 3, which is here. This is the graph of the given function f of x. Before we go, let's verify this using Desmos. Right now we have the graph of the basic square root function, and now let's change b to negative 2. Notice we have the basic square root function with a horizontal reflection as well as a horizontal compression by a factor of 1/2. Notice we have the key points 0, 0, negative 1/2, 1, negative 2, 2, as well as negative 4.5, 3. And now if we change c to positive 2, the graph is shifted right 2 units, which does verify our graph is correct. We have 2, 0, 3/2, 1, 0, 2, and negative 5/2, 3. I hope you found this helpful.